Hello, everybody. Welcome to my presentation. I'm Kitsiri Pereira. I have two co-authors, Takshila Gunawans and Ahmad Apan. We are from University of Southern Queensland, Australia, and Takshila works at Uvavillas University, Sri Lanka. I'm talking about the impact of greenery changes, how the forest area or greenery changes on human-elephant conflict in Sri Lanka, a model-based assessment using satellite data. I'm going to talk about the content here, introduction, research objectives, and also study area, data, and methods we used in this study. We are using Sentinel-2 data and human-elephant conflict data uh, taken from the government sources of Sri Lanka. So then talk about satellite data classification and the classification scheme and how we did image analysis and did the accuracy assessment of land cover and land use maps, then results, and also discuss about the influence of land cover changes on human-elephant conflict, evaluation of forest cover, and discussion and conclusions. In these two photographs, you can see how uh, close the wild elephants, to human life in Sri Lanka. One elephant is crossing one of the highways, and this is one of the electrical fences trying to keep elephants away from villages. Introduction. Human-elephant conflict is very crucial in Asia, one of the very crucial issues in Sri Lanka also. And in recent years, from 2015 to 2021, Sri Lanka has recorded nearly about 15,000 human-elephant conflict incidents. We will talk about those kind of incidents categories. Not only in Sri Lanka, other countries in Asia like Bangladesh, Bhutan, Cambodia, China, even in Thailand and Vietnam, there are uh, wild elephants in the environment. But in Sri Lanka particularly, it's quite critical. It's a small island, so the elephant can't go away from the island. And also the population is very high, and elephant density is the highest in the world in Sri Lanka if we calculate from the number of elephants and the land size. So when we check government data, human-elephant conflict uh, issues, incidents, there are many incidents recorded in nearly 54% is in open forests, not in the thick forest area, open forest area. That means forest area next to the thick forest uh, reservations. 62% were recorded within 2 kilometers from the forest edge. So the elephant deaths about is also increasing nowadays, and 51% of incidents reported in Sri Lanka in 2021, according to the data we collected, they're caused by explosive devices, electrocution, gunfire, train accidents, and toxic chemicals. Some are intentionally did by certain villages, or some are accidental, like train accidents. That unfortunately the issue is becoming critical. The one reason behind is the increase of rural population uh, from about 8 million to uh, 18 million, increased from 1960 to 2021. Within 60 years, it's a huge increase, more than double. So from the same time, the potential causes of human-elephant conflict in Sri Lanka includes shifting land use, because increasing population is going into the remote areas and new farming areas and other infrastructure is growing. And also elephants are losing their habitats. So this photograph also showing you how the village people are so close to wild elephants, and there's a electrical fence in between the forest and the village. The all these factors are worsening the situation. It's quite critical. So that's why there are many research works are working on this, and we are looking at this issue from a point of view of a satellite image application. The spatial pattern in Sri Lanka human-elephant conflict incidents, there are four categories we mapped: property damage, human injuries, human deaths, and elephant deaths. So all these areas you can see there's a kind of a similarity in the increase or maybe the higher number of incidents. Mainly these central and east Sri Lanka, except the northern area doesn't have much forest, but in the southeast, southwest, this part, people know in Sri Lanka there are huge population concentration in this area, and also this region we call wet zone, a lot of rainfall and less number of uh, human elephant conflict incidents. So we are going to explain further about this. So that if you think about human activities and map government hospitals, when there is an incident, how to reach the government hospital, we can see this least number of human elephant conflict area has more government hospitals because the region has more population, and also road network is also very good in this area. But as you see in this image, this ash color area has the more incidents are recorded. As I mentioned earlier, this is the region that we have wet zone because monsoon activities are quite aggressive and a lot of uh, agriculture and human activities are going on in this area. When the British Empire took control in the country in 1843, about 90% of the country was covered by forest. But from now, it's becoming nearly about 25% probably. Between 2010 to 2019, the forest loss rate was significantly high due to the country's rapid infrastructure development. So the elephant require a large area to meet their intake. Generally, average 150 kilogram of plant matter per day that they consume. So this photograph also showing how wildlife officers and the people uh, taking an elephant away from the village area to the forest to replace the particular animal. So it's quite critical situation in Sri Lanka. But for this research, we selected one of the regions in Sri Lanka which has a lot of forest area as well as significant amount of village activities, human activities. So we are going to do this research based on these research objectives. Finally, aiming, not we are not complete in this particular study, but the final aim is to do hotspot map of the country, which shows more high potential spots of human elephant conflicts. That's based on seasonal changes of the greenery of land. So then the government can take necessary action, mainly focusing on those hotspots. This study aims to develop a satellite data fusion approach to combine with GIS modeling to produce an accurate land use land cover map. Then we identify the human elephant conflict risk zones in that on that land cover map. This is the study area we selected, South Sri Lanka. So one of the quite big, large area which has a significant amount of forest reservations of Sri Lanka. Data. We used mainly satellite data Sentinel-2, which is one of the very useful high resolution. High resolution means from 10 meter to 20 meter to 60 meter, especially 10 meter data. So we have selected 4 data sets to combine to make the mosaic of this particular region. And the satellite data we have taken from 2022 data. This is the date actually. And the incident data, human-elephant conflict incident data, we collected from 2015 to 2022 from the Department of Wildlife Conservation in Sri Lanka. Classification scheme. Classification scheme is important. We considered mainly focus on forest and non-forest area, and also to produce the map with forest and open forest area. So image-based definition is here, forest, open forest, and how the thick or maximum conditions are here, and the minimum conditions are in this end. These are some of the image samples we observed and produced this 1, 2, 3, 4, 5, 6, 7 land cover, land use categories for the map. Why we call land use means we consider this homestead, other crops, these are the human activities. So that's why we call land use and land cover. For the image classification, we used 3 popular classification algorithms: support vector machine, random forest, and object-based image analysis. Generally, when you do land cover mapping, we are doing the most common old land classification system, image classification system, maximum likelihood. But in this case, these are new, recently developed methods. So we want to compare these 3 methods and then select the best one to use our land cover land use map. So I have added a few diagrams also to represent each type. But we are not going to discuss in detail about this area. We are going to explain the results and how we trying to focus on this human-elephant conflict mitigation. So we produced 3 maps, as you see here: support vector machine, random forest, and object base. So all 3 maps are significantly, I mean, reasonably did the classification for main large forest area. But as you see here, these regions are not similar. This has the forest area, but this is open forest, and this is a mixture of that. And also you can see a lot of inland water patches here, which is not 100% correct. But in this map, it has reasonably mapped the inland agriculture, paddy lands in yellow color. So then we do the accuracy assessment and found the random forest, this particular one, random forest, is the most effective classification method that we can, based on our rest of the research work. Actually, these 2 types, support vector machine and random forest, are having high accuracy values, but random forest has the highest value. Then we use that particular algorithm to produce the map like this. So this has 7 classes, as we mentioned. Forest, open forest, homestead farms. The colors are quite close because homestead and other crops are a mixture of greenery, and quite common that elephant access those areas because they can find a certain amount of food even from the village areas because a lot of mixture of various kind of vegetation like paddy fields, banana, other vegetables, and other perennial crops. The random forest classification map we used to do the rest of the study, and then overlap the human elephant conflict data on this map. And as you see here, some example sites we have selected. Each site with 2 kilometer buffer, 2 kilometer buffer, because 62% of the incidents we collected are recorded within about 2 kilometers from the forest area. When we see that it's close to forest area reasonably, and so again I have written here that how people kill elephants that we mentioned once earlier by in under the law the killing elephants is prohibited, that's illegal. But unfortunately, due to the severity of the conflict, there are illegal people are attacking elephants because many elephants incidents are causing human deaths also. It's a very critical issue. But this forest cover is not the same throughout the year. Then we used NDVI classification to identify the greenery of the land. So this image is showing the NDVI value. The high value are in this area, in this dark green to green area. So the objective of this combination of NDVI with the land cover map is to observe more weekly or at least bi-weekly greenery changes to identify where the dry area and where the greenery area are located. So then we combine that map with the historical human-elephant conflict data, then can do a kind of prediction, the possibility of next high activity region. So the study we discussed the human elephant issues, and I have just listed some of the information here. People are taking elephant to the outside area and put electrical fences and so many approaches, but still the problem is not fully mitigated and it's critically going on. So we use Sentinel data, and also it's a kind of a GIS approach, taking data top of each other and try to finalize the hotspots in the next step of our study. And the final aim is to produce the whole Sri Lanka map with potential high risk areas of human-elephant conflict. Okay, thank you for attending the presentation. And if you have questions, you can ask. Thank you.